All right. Hello, everyone. On behalf of Cenosco, it is my pleasure to welcome you to our 25th Asset Integrity webinar. My name is Ivana. I am the event strategist here at Cenosco, and I will be hosting this webinar. Today, we're going to dive into the topic of emerging approaches to risk-based inspection. We're pleased to welcome Cenosco's domain expert, Rowan, to this discussion. Rowan is head of domain experts at Cenosco and a chartered professional in integrity, materials, and corrosion with over 13 years of technical and leadership experience in the energy industry. Hi, Rowan. How are you doing today?
I'm doing great, Ivana. Happy to be here.
Then I would like to welcome Tomislav. Tomislav actually jumped in last minute to do this webinar in place of Arvind Singh, who had personal matters to attend to. So thank you for that, Tomislav. He is an experienced engineer and technical communicator with over 20 years in complex systems, modeling, and project management. As a technical writer at Cenosco, he translates engineering concepts into clear, user-friendly documentation for software in the oil, gas, and refining industries. Hi, Tomislav. How are you doing today?
I'm excellent. Thank you. It's a pleasure to be here.
Perfect. As said, today in our discussion, Rowan and Tomislav will go over emerging risk-based approaches. Following the discussion, we'll open the floor to questions. We have already received a few in advance, but please feel free to drop any additional questions in the chat. If we don't answer them now, we can also get back to you via email post-session. Lastly, please note if for any reason you experience a bad connection, a refresh of your browser will normally do the trick. All right, it's time to move on to the discussion. Rowan and Tomislav, the floor is yours.
Okay.
Thank you, Ivana.
Thank you, Ivana.
Yeah, I guess before we move on to the discussion of modern dynamic risk-based approaches to inspections, it's probably worth talking about the approaches that are currently in place. Understanding these methods is key to appreciating how dynamic RBI has the potential to transform asset integrity management. So the first of the approaches, the traditional approach, is that of time-based inspections. This method schedules inspections at fixed intervals, think every 6 months, annually, or every 10 years, whatever it might be, regardless of an asset's condition or risk. It's simple and easy to implement, relatively easily accepted by regulators. For example, a tank might need to be inspected every 5 years, so you inspect it every 5 years, no questions asked. But there's a problem with time-based approaches. They don't generally account for changes like unexpected wear or operational shifts in an organization. This can lead to over or under inspecting low risk or high risk assets, respectively, which could result in failures. It's a one-size-fits-all approach that lacks flexibility in today's data-driven world. Next up are qualitative inspections. This approach, the qualitative approach, relies on expert judgment and experience to assess risk. Inspectors rely on checklists, visual assessments, or historical knowledge to prioritize inspections. For instance, an experienced technician might flag a corroded pipe based on its appearance and past maintenance records. Qualitative methods are great for smaller operations or when monitoring data is scarce. They're often relatively quick to implement. They don't require complex tools. However, they can be subjective. Different inspectors might prioritize risks differently, leading to inconsistencies in risk evaluation for an asset. And without hard data, it's tough to justify decisions on an organizational level or to optimize maintenance schedules effectively. Moving on to semi-quantitative inspections, inspection or risk assessment methodologies. This method blends expert judgment with some data-driven metrics. It often uses scoring systems or risk matrices to rank assets based on factors like failure likelihood or consequence of failure. This approach is more structured than qualitative methods generally and helps prioritize high-risk assets. It's widely used in the oil and gas industry and has significant acceptance among regulators across jurisdictions. But it still relies partly on those subjective inputs, and the data used is not often real-time data. So it limits its precision in modern dynamic data-driven environments. Finally, we have these quantitative approaches. Currently, this is the most data-intensive approach in use. So these quantitative approaches collect detailed numerical physical data from equipment. They use statistical models and apply probability calculations to assess risk. Think of using sensor data to predict a pump's failure probability based on vibration patterns, temperature, or predicting corrosion rates in pipes based on quantitative methods. Common in advanced RBI programs offer precision and repeatability, making them ideal for complex systems like those in refineries or petrochemical plants. The downside, well, they require robust data collection systems, skilled analysts to analyze the data, and significant investments. If your data quality is poor, the results can be misleading. So, I mean, those are the four general approaches in place: time-based, qualitative, semi-quantitative, and quantitative. Each of these risk evaluation models approaches has their own strengths and weaknesses, but that's what we're left with now. The purpose of this webinar is to look forward, to identify whether or not we can apply new approaches to risk evaluation, to risk assessment, and evolve our risk-based inspection methodology based on the new data sources, new models that are available to us. Rowan, given the different data needs for each of these approaches, how does an organization's digital maturity level factor into the approach that they apply at their site or in their operations?
Yeah, good question, Tomislav. I think you rightly covered upon where we stand today, right? Conventionally, and as of today as well, there are various approaches: time-based, risk approaches, qualitative, semi-quantitative, quantitative. Again, just like what you highlighted, right? There's no one size fit all. I think it's really important to consider what is the organization's risk tolerance, what is the data availability, how much time, resources can we dedicate for such activities. And in most cases, right, the trend that we see is that most organizations are fairly comfortable adopting like a semi-quantitative approach. It's not too qualitative, so that the accuracy could be improved, because qualitative RBI approaches typically deal with a lot of judgment, expert opinions. So it's fairly subjective, right? On the other side, fully quantitative methodology needs a lot of time, effort, investment, and also the data to back it up as well. So most organizations are somewhere leaning in between in terms of combining qualitative approaches and not going extensively towards quantitative approaches. And that way, most organizations are trying to balance accuracy and flexibility as well. I think those are some key aspects with where the industry is typically standing. Now, again, we're talking about where the vast majority is. Of course, there are a number of organizations that are fully onboarded into quantitative methodologies. There are some organizations who are just moving away from time-based, stepping onto risk-based approaches. So starting with the qualitative approach, identifying the critical assets, and then maybe looking at performing extensive quantitative assessments for the critical assets could also be some approaches as well, right? So this is where industry typically stand, as you have highlighted, Tomislav. But how are the systems laid out to support that, right? Of course, when we talk about RBIs, risk assessments in general, right? Usually there are three primary factors. One is your processes, procedures. Number two is your systems, the systems that accommodates how RBIs could be executed. Number three is the adoption by the people as well. So these are three aspects that are key when it comes to driving successful risk assessment programs. And the way we see how industry is working, right? As you could see from this slide out here, pre-digital is still has not gone away. We still see paper-based data collection systems, still heavily relying on human inputs to drive or update RBI programs. So I personally, not too far away, like a few years back, have worked with Excel sheets and RBI and Word files in terms of updating RBIs. But again, when you think about it, right, when you zoom out, when you think about it, is that really scalable? Probably not, right? And much more onerous in terms of efforts required, in terms of updating assessments, and also prone to errors, right? A lot of manual work eventually can lead to errors in the programs as well. So pre-digital, I would say, was still not gone away. There are still paper-based methods or systems still in practice as of today. However, majority are somewhere between pre-digital, digitally reactive, and maybe entering towards digitally purposeful as well, right? So their digitally reactive typically means maybe a siloed system only for RBIs. So you might have an RBI software, RBI tool. You get inspection data from an IDMS or inspection management system, get all the inspection results, corrosion rates. We take the results, update our RBI tool or RBI software. So the RBI tool is still siloed. It performs, and based on input parameters, based on assessments, we would get inspection dates, intervals, and the scope of work. We typically take data from the RBI system, update our IDMS or update our CMMS programs to reflect the outcomes of the RBI approaches, right? So this approach as well, again, it's not scalable, right? You have an RBI system, okay, it's digital systems, less prone to errors. You have a specific methodology in place. But again, the scalability is also a big question out here, right? How can we scale this? How can we ensure we don't transfer data from one place, from an IDMS to my RBI program? At the same time, we don't manually export data and then transfer it to back to an IDMS program or to a CMMS system, right? So siloed systems, majority of the IT teams that we speak with, that we work with, this is also one big focus for IT teams across the globe. Get rid of data silos, have a centralized database, centralized management in terms of not just RBIs, your complete integrity management program, right? And RBI is a part of it. And like I said, most organizations, when it comes to risk-based approaches, are sitting somewhere pre-digital or under the digitally reactive sections, and they're aiming to move towards digitally purposeful or digitally integrated, right? So digitally purposeful, just like what I highlighted, is more of a centralized integrity management database, which collects data on the back of inspections, allows users to analyze their data, identify, let's say, corrosion rates, key critical factors that could contribute to your risks, typically carry forward those results to your RBI program, update your RBI program, come up with inspection results findings, and then your inspection plans and your reports are typically updated accordingly as well. That is what digitally purposeful typically mean. But there's still an element of siloed aspect here, right? Because your centralized IDMS along with RBI system is really not communicating with external systems, because most organizations work with a CMMS, EAM system like SAP, like Maximo, for example, right? Eventually, work order management is typically carried out in such a system. And that is where integrations come into place, right? So once you complete an RBI, once we know what needs to be inspected when, the outcomes of those RBI are typically fed back, of course, to the IDMS system, but integrating to a CMMS system, create work orders, generate work orders, plan next actions would take organizations to the next level in terms of improving operational efficiencies and also feeding in data to the RBI programs, right? Probability of failures are critical elements when it comes to risk-based approaches. Of course, you can take inspection data, but also keeping an eye on the process condition is also quite key. So IOW monitoring, integrating RBI programs to IOW monitoring, integrating RBI programs to sensors, just like what Tomislav highlighted, right? Those are also quite key. So yes, you might have a centralized IDMS and RBI system, but ensuring integrations are possible so that communications could be established to external systems. At the same time, we receive data, and there's no manual labor in terms of transferring data from one place to another really required out here. So most sites are aiming towards a digitally integrated. And the next step here is much more strategic, right? Okay, once we integrate these systems, how could we strategically leverage risk approaches for organizations, right? This is where dynamic risk models come into place. This is where continuous monitoring data come into place. Most of our organizations that we all work with, there are already continuous monitoring data systems in place. Data historians, IOWs, you can potentially get continuous data, continuous wall thickness monitoring, right? You typically getting wall thickness results on a continuous basis. Leveraging all this continuous monitoring data, processing that at scale, and dynamically updating your risk outcomes to understand your plans and actions is where typically the industry is typically proceeding towards to. And systems should be capable of accommodating such strategies, such processes, and such structures as well. Most systems today are somewhere between digitally purposeful, digitally integrated, but getting that next level digitally strategic is extremely key as part of this journey. And we, as part of Cenosco, that is where we are heading towards to as well. Today, we offer a complete digitally integrated system with very high value functionalities in our roadmap, ensuring that we become digitally strategic, allowing for dynamic risk assessments involving artificial intelligence models to drive decisions, to take integrity management to the next level as well. So this is typically what we call as a digital maturity framework, with an aim to move towards digitally strategic systems in the next 3 to 5 years.
So I think it's probably important to emphasize that this is a continuum more than, distinct steps that you might take through this maturity framework, right?
Of course, 100%, Tomislav. Like I said, right, some organizations could be pre-digital. Of course, having a 5-year, 10-year plan to ensure they become digitally strategic is the way to go. But of course, it's a step-by-step process, right? From pre-digital, you move to digitally reactive, to digitally purposeful, to integrations, to being much more strategic. So it is a continuous form of improvement and ensuring the value is provided accordingly.
Excellent. I think let's go back to talking about some of these traditional risk-based approaches. I don't know. I'll touch on a couple of points, maybe some of the benefits of these traditional approaches, and then I think you can talk about some of the gaps that the dynamic approaches might be able to solve with these, or at least improve with these traditional approaches. So one of the things I'd bring up is RBI, risk-based inspections, have definitely moved the industry from responding reactively to issues to developing more proactive cultures, for both on the safety, on the reliability, on the integrity fronts. So from that perspective, changing the culture of industry as moving from those time-based inspections to either qualitative, quantitative, semi-quantitative, whatever it might be, has definitely been a good motivator to improve that cultural maturity. And the second thing that I'd like to bring up, the benefit of adopting these risk-based approaches, is that it's been a step to improved acceptance of risk-based approaches by regulators. It's improved regulatory compliance. I think the recognition that we can achieve lower risk or better risk profiles in a number of different ways, and the fact that we've been able to communicate that to regulators and regulators have accepted it is definitely an asset for industry. So as long as we can achieve the same risk profiles or an acceptable risk profile and demonstrate that, many regulators are happy to accept those, different approaches to dealing with risk in an organization. I don't know, Rowan, maybe you can talk a bit about what are some of the downsides of the traditional approaches? What might be areas that we can actually improve using dynamic approaches?
No, good point, Tomislav. I think you touched upon the benefits quite rightly, right? Creating a proactive culture has been extremely important. Trying to justify to internal stakeholders, management, and also show compliance to external stakeholders, right? Regulatory bodies. Risk-based approaches have definitely excelled in that journey over the number of years. And of course, what are some improvements or some downsides that most organizations face as well, right? Risk-based approaches typically require updates, evergreening, as it used to be called. Once an RBI is done, an inspection plan is generated. Once inspections are executed, RBI typically are updated accordingly as well. So there is a level of continuous effort required in terms of updating RBIs, identifying risks, so which needs time, resources, and investment from organizations. So, and again, in most cases, I would not say in all cases, in most cases, this re-review of RBI happens manually. Usually, RBI teams group together, perform unit reviews, or on the back of inspections, they review inspection results and perform rerun the risk assessments proactively as well. So it needs a bit of continuous effort from organizations. That is number one. And of course, the review is being carried out fairly manually as well, right? So once we gather new data, the inspection results are reviewed. The inspection results which are reviewed are being incorporated into the assessments, and based on that, we understand the risk profiles, the intervals of the next inspection dates accordingly. What could also be a downside is susceptibility to delays between issue identifications and action, right? Because most organizations are operating with lean teams. And of course, every discipline is fairly busy with priorities as well. So yes, there could be an issue identified on the back of an inspections. Maybe there are RCAs happening on the sites, but in reality, RBI takes some time in terms of being updated and so on. So there's usually a bit of a gap or a delay between what was identified and the action of updating the RBI programs, right? And in some cases, this could pan out for months or even years because teams have been extremely busy with shutdowns, turnarounds, and other priority actions, and your risk assessments have still not been updated to reflect your latest risks based on your latest inspection results and findings.
So the systems are in place to encourage this continual improvement, but sometimes we fall down because, well, everyone's got competing pressures.
Exactly, Tomislav. Very well said. Systems are there, processes are there. The commitment to adoption is there, but due to, like you said, right, due to other priorities, due to other actions, sometimes rerunning RBI programs, evergreening RBIs kind of fall off, right? So that is an important issue that is common across various organizations as well. And one key aspect as well is most cases, risk assessments, evaluations are based on a confined data sets, right? So how are risk assessment being executed on the back of inspections? How are inspections being executed? It's usually performed by inspection contractors, inspection engineers, uh, delivering a specific inspection scope or an activity, and they typically record inspection results, inspection findings. So across a life cycle of your assets, let's say 20, 25 years, there's limited inspection data sets over the course of the asset life as well. And that is being used to drive decisions in terms of risks as well. So the continuous monitoring aspect and using continuous monitoring data as part of your risk assessment seems to miss. Although most assets have continuous monitoring capabilities in terms of sensors, in terms of process historians, IOWs, but effectively utilizing them and running RBI programs doesn't seem to be quite common within industries these days as well. So most organizations seem to assess risk based on limited data set. That is typically where we stand as of today, Tomislav.
So the risk of relying on those limited data sets is probably well, I mean, it can happen on the side of, let's say, having too high a factor of safety for some processes, resulting in inefficient extra inspections, whatever it is, or on the other side, right, where your safety factor ends up being too low, where you actually generate higher risk in your operations than is necessary.
Yeah, exactly. Operations could change, right? Processes could change. Ideally, in most cases, there should be a management of change processes. If it's plan changes to operations and process conditions, sometimes it could be unexpected as well. But ideally, what is not happening with the risk assessment is these changes in conditions could result in change in degradation rates, for example. And that degradation rate is not continuously used in terms of updating your risk assessments. Okay, you update your RBI 3 years back, but 3 years from today, things have changed. My degradation rates could potentially increase. So unless we revisit the RBI next time, that change in corrosion rate has not been really accounted. And once we have better visibility with changes in degradation rates and things like that, that gives sites much more confidences in terms of incorporating appropriate corrosion rates as part of the RBI or risk assessments, and then drive future programs accordingly as well.
Right. So I think we've covered the traditional approaches, kind of the downsides, the positives, and just kind of the background of them. Let's move on to these emerging risk-based approaches. What are some of the aspects we should keep in mind? What are some of the, let's say, benefits of these emerging approaches? I'll tackle this first one, the data gathering. I mean, the number of sensors, the number of new data sources that are available on the market, whether it's from, you mentioned continuous wall thickness monitoring, to moisture sensors for predicting CUI, and any number of other sensors. They're a dime a dozen. We can collect data from thousands of data points where we couldn't do so even 5 years ago. So there are these fantastic data sources. They provide real-time data. I think we need to have some sort of approach to analyzing all that data, to managing that data, and that's probably where dynamic RBI fits in. Collecting that data is one thing, but I mean, what do you do with it, Ron?
Yeah, good one, right? So I think you touched upon the first part. I think the industry is slowly moving towards sensors, collecting data on a continuous basis, for example. So continuous monitoring, that is number one, or collecting data at scale. advanced imagery, remote inspections, flying drones, getting a whole picture of your assets, and then running that through specific models and things like that. So the data collection is increasing quite exponentially, right? Historically, what would happen, or even conventionally, what would happen that is still happening in most places. Inspector goes out of the field, performs an inspection. It could be a visual inspections, it could be an NDT inspection technique, and inspectors are gathering inspection results, findings based on the inspection task or activity. Let's say they're doing ultrasonic thickness measurement, they're getting wall thickness results, which is being captured, and then that wall thickness result is being sent over for analysis, right? So that analysis will typically identify what are your corrosion rates. We will of course look at historical results and identify long corrosion rate, short corrosion rate, average corrosion rates, and then come up with due dates for inspections accordingly as well. So this is conventional way of data gathering, manual way of performing inspections, gathering data, analyzing the data, and using that data to drive decisions accordingly. Where the industry would typically head in 5 to 10 years, Tomislav, is there will be rapid adoption of these smart sensors, just like what you highlighted, right? Ultrasonic, permanently embedded ultrasonic thickness measurements that could provide continuous wall thickness results. Remote inspections, a combination of laser scan techniques, drones, other ways where you could perform inspections at scale. So you have a lot of data that you have in hand. So all that has to be processed. This is where step number 2 comes, right? What do we do with that data? So of course, today there are existing statistical models present to analyze that data. I think these models will typically expand, and this is where artificial intelligence, machine learning would typically come into place. Not only look at current data, look at historical trends, and then make predictions on how the data should be analyzed. And as part of the process, typically disregard outliers, data that does not really make sense, really use high quality data to drive your decisions. I think AI ML will play a key part out here. Um, One is analysis. Number 2 is also identifying specific types of degradation modes, mechanisms as well. There are quite a few tools in the market. Once you upload a radios RT image scan, at least there are some AI tools that could typically highlight what are some potential defects that we are looking at. It also provides some confidence bounds. I think with time, these models will rapidly improve. These models will get better, and the confidence of detection will also increase as well. So that way, rapid identification of defects, damage mechanisms, along with proactive analysis will be driven by AI ML systems in 5 to 10 years time.
At the present, are there, do you know of applications of AI machine learning? I mean, I can think of in our product, I can think of, you know, the air system that allows you to analyze drone imagery or photographic imagery to identify potential defects to insulation, to piping, whatever it might be.
Yep.
What can you think of any other applications?
Yeah, good one, Tomislav. I think we, as Cenosco, as a product, right, as a product company, we have products that typically satisfy data gathering and data analysis, step number 2 out here. So data gathering, as you have highlighted, right, we have a product called Air 3D, which typically allows you to perform a complete scan of your assets using multiple techniques. Drones could be one, laser scans, complete visual imagery could be another. And then based on all the scan data, we can process it through AI ML models and identify locations where external corrosions are typically are present. Most likely a screening tool. External corrosion is one, damage to insulation could be another as well. So instead of performing external visual inspections on a regular basis at specific part of your asset, you're doing an extensive external assessment across your entire asset in one go. And of course, you don't have to be doing this activity every 3 monthly or 6 monthly, right? Because corrosion, external corrosion, atmospheric corrosion on its own is time dependent. It takes time for external corrosion to degrade with time. So usually sites adopt revisiting. Running these assessments or running these technologies every 2 years, 3 years, sometimes even longer. So that way you do a comparisons and then make identify what your next action should be and things like that. So this is the data gathering. And also I touched upon the analysis aspect as well. But Cenosco's tool, Pressure Equipment Integrity, we have a number of data analytics capabilities. We are probably one of the only tool in the market that has statistical prediction capabilities for more than a decade in terms of wall thicknesses as well, right? So once you gather wall thickness from conventional NDT techniques such as ultrasonic radiography, there are statistical models clearly built to identify your anomaly locations, identify when there are extensive corrosion rates and what your next wall thickness results should be. And also extreme value analysis on tube bundles, again, based on statistical assessments. By performing inspections on limited number of tubes, we can extrapolate the results across the entire tube bundles and plan future inspections much more confidently. So these are some capabilities that are already available, Tomislav, and we will be looking to enhance, especially with AI ML algorithms, and especially our experience with AI ML algorithms with Air 3D and other aspects as well. Okay, so this is step number 2, right? We have gathered the data, we have analyzed the data. And how do we utilize the analyzed data, right? Where does this analyzed data typically go? And this is where adaptive risk models come into place. At the moment, right, I think Tomislav and I touched upon one of the previous slides saying that current approaches are still heavily driven manually. Future approaches will be fairly adaptive. So continuous update on real time with regards to probabilities, potentially with consequences. Responding to changes in operating conditions. If you have specific variables and if it's breaching those limits, the acceptance of exceedance limits, responding to that automatically is also quite key as well. So adapting your risk models based on continuous monitoring, good quality data, because step number 2 typically filters the noise and takes it away and provides a good quality data and uses that in terms of risk assessments and continuously updating your risk models accordingly. Okay, and of course, once you have an adaptive risk method, risk model, of course, you will have your criticality of your equipment well defined. Also gives you a bit more confidence because you're using continuous data, good quality continuous data to identify your criticality of your equipment. But the story does not end there, right? Ideally, it has to be fed back somewhere. And that is exactly the final point, the feedback loop. So once we run such adaptive risk methods, risk models, follow-ups will be much more quicker. So enabling automated decision making or semi-automated decision making as well in some cases, because there's usually a human involvement involved in terms of making the decision. So the human can take ownership in terms of what the decision is as well, but the tools and the models will drive that process much more efficiently and much more quickly. Also sending alerts, trigger, automating workflows. If you have a certain result, certain criticality, this should be the next workflow as a follow-up as well. So again, this is fairly futuristic, but this is typically where most people, most organizations, industry leaders are anticipating that the integrity management and RBI approaches will typically go towards too. So once you adopt or uh, uh, install a number of continuous monitoring data, those become your inspection points, inspection locations. Based on continuous data, you're updating risk models, and based on your risk criticalities, you can primarily focus on repairs, repair actions, replacement actions, and things like that, because you already have continuous monitoring sensors to drive inspections on a regular basis. So the most likely actions coming out from risk assessment is any other aspects that needs to be considered to reduce your risk. The second or the other actions would be when should you be prepared to perform repairs, replacements, and so on.
Interesting. I like this. We've got this point up here. I think it says learn from other assets and apply insights across your organization. I mean, it's rare that a company operates only one refinery or one plant. So I think it's of great benefit to be able to incorporate that data from those other sites and reduce risk across the whole organization. It's not what happens at one site is definitely going to happen at another site.
Exactly. Very well said, Tomislav. I think in 5-10 years time, that would be fairly, I think these kind of learning insights or having insights from one site and applying it to another using existing models and things like that would have taken place. There will be definitive use cases accordingly as well. So it's definitely it's definitely good to look forward to for such a world.
This sounds great. There's always a but, right? What are some of the challenges or obstacles to adoption? I think you touched on some of the things that are possible with these new data, dynamic data-driven approaches. How do we get from here to there? Right? That's there are obstacles in the way. From my perspective, I mean, IT and data infrastructure is a huge concern. Our product, the IMS, manages huge amounts of data, but the amount of data I think that is going to be necessary to manage to apply these dynamic approaches to risk-based inspections is an order or 2-3 orders of magnitude greater than the amount of data that we currently manage. So, definitely one of the obstacles, one of the challenges is going to be, investing in these IT and data infrastructure components in our companies. I mean, granted, a lot of it will be, like our product, either hosted in the cloud or managed. Your data will be managed by, by a third-party provider, data provider, that sort of thing. But it's still going to be a huge logistical challenge to implement these new systems. Any comments, Rowan?
No, agreed. Fully agreed to that, Tomislav. Technologies need stronger foundations, and especially software systems, software tools need to have an IT strategy. I would say strategy will govern a lot, and for that, the foundations have to be really, really strong. Just like what you highlighted, we will be dealing with volumes and volumes of data. How do we ensure things work quite well with handling such a volume of data, right? So ensuring there's a proper IT strategy, ensuring there is like a system that could accommodate that is really, really critical. Totally agree to that. Maybe one to you, Tomislav, because you come from a regulatory background as well, right? And all these futuristic technology sounds exciting, maybe shows some initial promise. But of course, the world that we are operating in, especially asset integrity, is quite common in asset-heavy industries, energy industries, which are extremely regulated, right? Almost every geography where you have sites, it's highly regulated. How do you think regulators would typically respond, especially as of today when there is no clear definitions of standards and guidelines of such ways of working? What do you think would be a regulator's response to such an approach?
So I would begin by saying if there is an industry standard of some sort, API or ASME or whatever it might be to some sort of dynamic RBI, that would be the easiest way to accept that as a regulator. In my career as a regulator, I think what we typically ask of proponents that we're looking to drive to use new risk approaches, new assessment approaches in their organizations would be to run both approaches in parallel. So, and except you're using one of your traditional RBI approaches, at the same time you use your dynamic approach to RBI, and you show us that the outcomes are the same. Typically, there are obviously going to be some intransigent regulators, but typically regulators are happy to achieve the outcome, particularly in strategic industries like oil and gas. These are relatively high stakes industries. If it can be demonstrated that the risk profile is similar before and after the change, I think it's a bit of a no-brainer for the regulator to accept the changes.
Mm-hmm.
There's obviously benefit to being a large firm that has experience in dealing with regulators across throughout the globe. It's probably easier for them to sell these approaches to different regulators than it would be for a small operator that only operates in one jurisdiction or only has a couple of plants. So there will be those trailblazers, the larger firms that can afford to invest in these new systems, these new approaches. But eventually the other operators will piggyback off those successes and use those when talking to regulators.
No, good points. I can tell you my perspective as well, Tomislav. We have dealt with regulators currently in the past as well. We deal with regulators currently, and we have dealt with regulators in the past as well. And in almost all cases, right, regulators are fairly open as long as we put forward to a regulator that there is an approach that is much more effective, efficient, and it gives organizations much more control of their risks of their respective aspects. Almost all regulators are ready to listen. Of course, they will review, provide their feedback, and eventually adopt such a working model as well. And just like what you highlighted, right, it's a process. This will not happen overnight. There will be hundreds and thousands of pilot projects happening, focusing on specific equipment, specific unit, and slowly we would scale it up with regulators involved in each of these processes over time as well. And maybe other challenges, obstacles, change management, cultural resistant. If something is working good, why do we change? I think that is usually the question that is already that usually gets put forward, right? If there is a robust RBI program that is working, why do we have to take it to the next level? This is already working. People have already adopted, so that typically works, which is fair enough, right? So some organizations, it may not be a need for certain organizations, but certain organizations who want to be technology leaders could be slightly biased towards dynamic risk approaches and so on. And one key aspect is the expertise, right? Of course, once models are involved, once AI, machine learning algorithms are involved, it's also quite important to develop in-house expertise to ensure and understand how these models work, to typically validate respective results and outputs as well. I think that is quite critical as well.
So those are the challenges. Those are some of the obstacles. I mean, there are obviously many challenges and obstacles, but I think that just touches upon some of them. What are potential benefits?
Good question. It's still too far away to come up with a very high value use case unless a number of pilot projects have done to really signify and quantify the value. But on a high level, this is where we typically anticipate where ROIs could be achieved, right? Um, Number one, downtime savings, improving operation efficiencies. Number two, improved safety and reliability could be number three. And with this, I think we could free up a lot of time for people who's working in assets that are typically doing repetitive manual tasks, so that their focus could be on other critical areas of the organizations as well. So with much more continuous assessments, we would have better understanding and control with regards to our risks. So potentially unplanned downtimes could go down. Of course, a lot of aspects has to go right to come up with that specific statement. Increasing operational efficiency, I think this will be one of the biggest benefits, right? Most organizations in today's world, we don't quantify the operational efficiency of incorporating a new system, a new process, a new way of working. So in some cases, a lot of manual work will be removed. So which means that people may not have to spend 200 hours on a specific task that they are spending today. Uh, yeah, with a much more collaborative working system, with automations, with dynamic risks, with automated actions and things like that. There's definitely a lot of room in terms of improving of operational efficiencies. And of course, improved safety and reliability, right?
Right.
I think one of the key premise is enhancing our dependency with continuous monitoring. So, which means that less people are being exposed in sites in confined areas, and ultimately the risk to people is significantly reduced. And of course, once we have savings in terms of man hours durations, we could typically use human resources at much more critical aspects, tasks. And maybe one of the aspects that we touched upon is to really understand how these models work and ensure they provide the final validation. So they are the risk acceptor in terms of what
Right.
the tool system or the models typically provide as well. I think this is some key benefits. And of course, there will be a number of pilot projects happening. There'll be a number of ROI quantifications done with these pilot projects. And on a high level, this is exactly what we think would be some quantified ROI benefits.
Great. No, that's it sounds compelling, but I think it's obvious that the return on investment for something like this can't be calculated in months. It's more years to decades, which is the lifespan of these facilities. So.
Exactly. It is a process, right, Tomislav? I mean, 10 years back when people were saying that autonomous vehicles wouldn't exist, I mean, today when you look into the world, I think that is slowly changing, right? So
Right.
again, it's very, very similarly. People have always said energy industries is a bit resistant to change in overall. But I think the last 3, 4, 5 years, or even the decade, organizations have chosen to change, or organizations have shown a strong intent towards technology adoption and things like that. So I
Right.
think with strong use cases, with strong justifications, it's only a matter of when, I would say.
Gotcha. Rowan, I think it's almost time for us to wrap up. Are you willing to entertain a couple of questions that we got just before we sign off?
Yeah, should be fine. Maybe we could just take one question, Tomislav. I think we've gone past our time, so maybe just one question, and then we can hand it over to Ivana.
Sounds good. So this was an interesting question that was submitted before one of the participants before the webinar. It says one of the elements in dynamic risk-based inspections is the risk target, and then he goes on to talk about it a bit. Do risk targets change as part of these dynamic approaches to risk, or is it just the risk assessment, the risk evaluation that changes.
Now, I think the risk evaluation changes because with current processes, right? I think this could be coming from quantitative risk methodologies, where we would define risk targets, identify probability of failures, consequence of failures, and check when we are breaching the respective risk targets, right? Risk targets potentially is defined by stakeholders within the organizations. That is the acceptable tolerance for an organization in terms of risk. What will change is the way we perform probability of failure assessments. Today, we're just taking a corrosion rate, maybe carried out on the back of an inspection 2 years before, and we're using it as part of a risk assessment to drive our criticality values. So what will change is that input in terms of corrosion rates will be much more driven by continuous monitoring data, UT sensors, IOW variables, incorporating IOW variables in theoretical prediction models, and coming up with a much more suitable, appropriate, and live degradation rates, and driving your risk outcomes accordingly. I think this is exactly where things would typically change. What are your thoughts on that?
No, I think that's fair. I think that that makes sense. Our appetite to accept risk is not going to change. It may even improve for the better as time goes on. But definitely, it's not. I don't think those risk targets are going to change as part of any of these dynamic approaches. It's just how do we achieve that risk? How do we ensure that we maintain or that we keep our risk below those risk targets?
All
I
right.
think
Well,
I think that. Sorry, I'll turn it over to Ivana. I think we're done for today. So.
thank you so much, Rowan. Tomislav, our time has run out. And thank you again for all the viewers watching. Thank you for your time as well. Please take note that this webinar will be available to download shortly from our website. And before I go, I would like to mention that we are already planning our next webinar focused on the functional safety in the digital era. This will take place on August 26th, so please stay tuned. For all the viewers, Tomislav, Rowan, thank you all so much and have a great day ahead.
Thank you.
Thank you, folks. Thanks for tuning in. Cheers.